So let's get started with addition of vectors concepts. So first, moving on to the concepts of addition of vectors, you should know what is a scalar and what is a vector. So let us take the definition of a scalar. So a physical quantity having magnitude is called a scalar. Example: length, mass, area, volume, temperature, speed. These are all scalars. Now let us see what do you mean by a vector. So a physical quantity having both magnitude and direction is called a vector. What are the examples of vectors? Displacement is a vector. Velocity is a vector. Acceleration is a vector. Force is a vector. Angular momentum is a vector. Then next, coming to modulus of a vector. What do you mean by modulus? So if a vector AB bar is denoted by A bar, then mod A bar denote the length of a vector of A bar. Also mod A bar is called magnitude or modulus of vector A bar. Next, let us understand what do we mean by collinear or parallel vectors. So vectors along the same line or along the parallel line are called collinear vectors. And we have a condition: two vectors A bar and B bar are parallel or collinear if and only if A bar is equal to TB bar, where T belongs to R. Next, let us see what are like vectors. So, collinear or parallel vectors having the same direction are called like vectors. Now see, this is a line. A, B, C are the points. Now AB and BC both are collinear vectors because they are in the same direction. Now we have unlike vectors. So collinear or parallel vectors having opposite direction are called unlike vectors. So AB is a vector, its direction is from B to A, and CD is a vector, its direction is C to D. So you can see these two are parallel vectors, but they are opposite in direction. Hence they are called as unlike vectors. Now next is unit vector, very important. A vector whose magnitude is unity. Unity means 1. Whose magnitude is 1 is called as a unit vector. So the unit vector in the direction of vector A bar is denoted by A cap, and modulus of A cap is 1. Now here 2 points to be noted. Unit vector in the direction of A bar is A bar by mod A bar. Number 2, unit vector in the opposite direction of A bar is minus A bar by mod A bar. So if it is in the direction, it is positive. If it is in the opposite direction, it is negative. Now after unit vector, we will see what is position vector. So if a point O is fixed as origin in the plane and A is any point, then OA bar is called position vector of A with respect to O. Now coming to the most important topic, that is triangle law of addition of vectors. Triangle law of addition of vectors. So let's take a triangle here. This is O, A, B. This is A bar vector. This is B bar vector. So in a triangle OAB, let OA bar equals to A bar, AB bar equals to B bar. Then the resultant vector OB bar is defined as OB bar is equal to OA bar plus AB bar. So two vectors taken in same order, if you add them, it is equal to the third vector taken in reverse order. That is triangle law, which is equal to A bar plus B bar. And this is known as triangle law of addition of vectors. Now let us see what is section formula. Now let A and B be 2 points. With position vectors A bar and B bar respectively. Let C be a point dividing AB internally in the ratio m:n. Then the position of C is OC bar is equal to MB bar plus NA bar by M plus N. See, A and B are 2 points and C is a point somewhere in between them. So A is given by A bar, B is given by B bar, and this ratio is M and N. So OC bar is MB bar plus NA bar by M plus N. This is if it is dividing internally. And if it is externally, then let A and B be 2 points with position vectors A bar and B bar respectively. Let C be a point dividing AB externally in the ratio m:n. Then the position of C is OC bar equals MB bar minus NA bar by M minus N. So this is section formula. Now let us see midpoint formula. So write a point. The position vector of the midpoint of the line segment joining two vectors with position vector is A bar plus B bar by 2. Now let us see what are coplanar vectors. So 2 or more vectors are said to be coplanar if they lie on the same plane. Now in this there are 2 points to be noted. The vectors A bar, B bar, C bar are said to be coplanar if and only if scalar triple product of ABC is 0. And number 2, four points A, B, C, D are said to be coplanar if and only if scalar triple product of AB bar, AC bar AD bar is equal to 0. Then next point to be noted, very important, 3 points A bar, B bar, C bar are said to be linearly dependent if and only if scalar triple product of A, B, C is 0. And 3 points A bar, B bar, C bar are said to be linearly independent if and only if scalar triple product of A, B, C is not equal to 0. So moving on to vector equations of a straight line. So first point to be noted is the vector equation of the straight line passing through the point A of A bar and parallel to the vector B bar is R bar is equal to A bar plus TB bar, where T belongs to R. Then the second point is the vector equation of the line passing through origin O and parallel to the vector B bar is R bar is equal to TB bar, where T belongs to R. Next, moving on to Cartesian equations. Or you can say Cartesian form. So Cartesian equation for the line equation passing through A x1 y1 z1 and parallel to the vector B bar if B bar is equal to Li bar plus Mj bar plus Nk bar, then the Cartesian equation is x minus x1 by L equals y minus y1 by M equals z minus z1 by N. Then next is, this is the first point, and the second point is the vector equation of the line passing through the points A of A bar and B of B bar is R bar is equal to 1 minus T into A bar plus TB bar, where T belongs to R. Then one more point, Cartesian equation of the line passing through 2 points AX1 Y1 Z1 and BX2 Y2 Z2 is x minus x1 by x2 minus x1 equals to y minus y1 by y2 minus y1 equals to z minus z1 by z2 minus z1. So moving on to the last topic, that is vector equations of a plane. So here you have three equations. So the first one is the vector equation of the plane passing through the points A of A bar and parallel to the vectors B bar and C bar is R bar is equal to A bar plus TB bar plus SC bar, where T and S belongs to R. Then the second formula is the equation of the plane passing through the points A of A bar, B of B bar and parallel to the vector C bar is R bar is equal to 1 minus T into A bar plus TB bar plus SC bar, where S and T belongs to R. Moving on to the third formula, the equation of the plane passing through three non-collinear points A of A bar, B of B bar, C of C bar is R bar is equal to 1 minus T minus S into A bar plus TB bar plus SC bar, where S and T belongs to R. With this, all the concepts are completed.